Welcome to another video lecture. In this video lecture, we are going to discuss about the problems based on the second order system response for the underdamping case. So before going into the problems, let me first summarize the findings of this topic. So the second order system is having transfer function, general expression of the transfer function Cs by Rs is equals to omega n square divided by s square plus 2 zeta omega n s plus omega n square, where omega n is the natural frequency. It is the natural frequency in radian per second, and zeta is damping ratio. It is the damping ratio. Now the response of this system for the unit step input comes out to be Ct equals to 1 minus e raised to power minus zeta omega n into t divided by 1 minus zeta square into sine omega d t plus theta, where theta was tan inverse square root 1 minus zeta square divided by zeta. So this was the response of this second order system when we apply a unit step input. Now we also define some parameters for this response. First one was the peak time Tp, which comes out to be it was pi by omega d, where omega d was the damped frequency. It was omega n into 1 minus zeta square root. And next one was the maximum overshoot, or sometimes known as peak overshoot, maximum overshoot. Next parameter mp, as value comes out to be e raised to power minus zeta pi divided by 1 minus zeta square. Next parameter was the rise time. The value was Pr equals to pi minus theta divided by omega d. Again, omega d is this damped frequency. And the final parameter was settling time. The value of settling time was for 2% tolerance, it was 4 into t, and t was zeta omega n. This is for 2% tolerance limit, and for the 5% tolerance limit, it was 3 divided by zeta omega n. This is for 5% tolerance. So these are the major parameters and equations which we have already seen in the second order system for the underdamping case. Now let us solve some numerical problems. Okay, so now the first problem is a unity feedback system has open loop transfer function. So the value of a GS, the open loop transfer function, is given k divided by s plus 10, and we need to find the value of k for the system to have a damping ratio equals to 0.25. This question was asked in the GATE examination, GATE 2015. So in this question, we need to find out the value of k, the gain, for the system to have a damping ratio equals to 0.25. Now, if you can remember the standard form, first of all, this is the unity feedback system. So the value of Hs for the unity feedback system is 1. The value of Gs is given. Now we know the transfer function of the closed loop system is given by Gs upon 1 plus Gs Hs. This is the transfer function of the closed loop system. So the value of Gs is given as k divided by s plus 10 divided by 1 plus Gs k divided by s plus 10 multiplied by Hs, which is 1. So first of all, what we need to do, we need to calculate the transfer function of the closed loop system. If an open loop system is given in the question, then we need to calculate the closed loop transfer function, which is given by this expression Gs upon 1 plus Gs Hs, and the value, since it is given that this is a unity feedback system, so the value of Hs is given as 1. So let me complete this. The transfer function comes out to be, let us solve this. So we can take the s into s plus 10 in the denominator. So this will comes out to be k divided by s. So let us multiply this s square plus 10s plus k. So this is the final value of the closed loop transfer function for this given system. Now we can compare this transfer function value with the standard equation which we have already seen in the previous slide. So the transfer function, general expression of the transfer function of the second order system is omega n square, s square plus 2 zeta omega n s plus omega n square. Now, if we can compare these two equations here, this and this, we can say that the value of omega n square is equals to k, or we can say omega n is equals to under root k, and the value of zeta, we can compare these two values here. So, the 2 zeta omega n will comes out to be 10. We can put this value omega n here, and it is also given in the question the value of damping ratio zeta is given. Since omega n is under root k and zeta is equals to 0.25, I can put these values in this expression. So, this 2 into 0.25 into under root k is equals to 10. Now, we can solve this for value k. So, finally, this value k comes out to be 400. So, this is how we will solve these type of numerical problems. So, this is the second problem. In this problem also, open loop transfer function is given with the unity feedback system. GS is given to us. Again, the open loop transfer function is given with unity feedback system. And for this system, the peak overshoot of closed loop system for a unit step input is given, which is the 10%. So, this time the value of peak overshoot or maximum overshoot is given, and we need to find the value of k. Now, this question was asked in the GATE examination 2016. So, in this question also we need to calculate the value of k, but this time the value of peak overshoot is given. So, how to solve this problem? Again, we need to find out the closed loop transfer function of this system. Again, we use the same concept. The transfer function of the closed loop system is given by Gs upon 1 plus Gs into Hs. Again, the value of Hs is given as 1 and the value of Gs is given as k divided by, let me multiply this, s square plus 2s. So, I can put these values in this equation. So, the transfer function value comes out to be k divided by s square plus 2s divided by 1 plus k divided by s square plus 2s into 1. So, this value comes out to be k divided by s square plus 2s plus k. Now, we can compare these with the standard equation, which is omega n square divided by s square plus 2 zeta omega n s plus omega n square. So, if we can compare these two equations, this and this, we can say that the value of omega n is again square root k, and the value of 2 zeta omega n is equals to 2. So, here we can say the value of zeta is 1 by omega n. So, this is 1 by square root k. Now, we already derived the expression for the maximum overshoot MP. The value of MP is e raised to power minus zeta pi divided by 1 minus zeta square, and this value is given as 10%. So, without, if we convert this without percentage, so this value is 0.1. So, from this equation we can put this value 1 minus zeta, again zeta is given 1 by square root k and divide by 1 minus zeta square. So, this will be 1 by k, and this value is given as 0.1. We can take log on the both sides, and you can solve this equation for k. So, if we will solve this equation for k, it will comes out to be approximately 2.8. So, this is how we will solve these type of problems in which one parameter is given and the value of gain is asked in the question. So, either maximum overshoot is given, either the value of peak time is given or rise time is given, and the value of gain again k is asked in the questions. In this last problem, a closed loop system is given with the open loop gain and feedback gain, and we need to find the value of constants, these gain k1 and k2, so that the value of maximum overshoot is given 25% and the value of peak time Tp is given as 4 seconds. So, in this problem we are given two parameters, and we are asked with two parameters k1 and k2. So, how to solve this type of problems? Now, again we need to calculate the closed loop transfer function of this problem. So, these two blocks are in series and these are connected with this block 1 plus k2s in feedback. So, we know that the overall transfer function of the feedback system is Gs upon 1 plus Gs Hs. Here Gs is k1 divided by s square, since both these blocks are in series, k1 and 1 by s square, and the value of hs is 1 plus k2s. So we can put these values in expression this. The transfer function of this closed loop system comes out to be k1 by s square divided by 1 plus k1 divided by s square multiplied by 1 plus k2 into s. So this will be k1 by s square plus k1 k2 into s plus k1. So this is the final expression for the transfer function. Now we can compare this with the standard equation, which is omega n square divided by s square plus 2 zeta omega n s plus omega n square. So we can get the value. Omega n is again square root k1, and this 2 zeta omega n will be k1 k2. So I can write it as under root k1 into under root k1 into k2. So this will be 2 into zeta into omega n is under root k1. So this will be under root k1 under root k1 into k2. 1 under root k1 is get cancelled. So zeta is under root k1 k2 divided by 2. So again I have determined these values omega n and zeta, and these two parameters is given. So first of all TP, TP peak time is given. So we know that formula for the peak time is pi by omega d. So this is omega n 1 minus zeta square. So this value is 3.14 divided by omega n is square root k1 into 1 minus zeta square. So zeta square is k1 k2 square by 4, and this value is given as 4. So let us this equation be equation number 3, and one more parameter is given, which is MP 25%. So the MP formula for MP is e raised to power minus pi zeta divided by square root 1 minus zeta square. So let me put these values. E raised to power minus pi 3.14 into zeta. Zeta is under root k1 k2 divided by 2 divided by square root 1 minus zeta square is k1 k2 square by 4, and this value is given as 0.25 if I will convert this without percent value. So this will be 0.25. This equation is equation number 4. Now we have two equations, equation number 3 and equation number 4, in which we have two unknown values k1 and k2. So we can solve this equation for k1 and k2. So I am not going into the details of how to get these values. I am just writing the final values of k1 and k2, which comes out to be k1 will come out to be 0.7369 and k2 will come out to be 0.9405. So these are different type of questions which can be asked based on this second order system. Thank you.